right, let's review all of our derivatives, exponential and log derivatives. All right, and the first one is the product rule. All right, so we have derivative of product. As a reminder, the product rule. Let's see if I have room to put it in here. So we have, if we have the derivative of a product, that's going to be the first times the derivative of the second plus the second times the derivative of the first. Right? So we've got x cubed, and the derivative of x cubed is 3x squared. Actually, let me write that as, instead of a prime symbol, let me put db. Looks a little clearer. Right, so u is x cubed, du is 3x squared, v is e to the 2x. This would be a chain rule. So we're going to have the derivative, we're going to have e to the 2x times the derivative of 2x. Right? And the derivative of 2x is just 2. So this is going to be equal to 2e to the 2x. Right? So the derivative f prime of x equals x cubed times 2e to the 2x plus 3x squared. Uh-oh, I'm coming too close to this one over here. All right, so plus 3x squared times e to the 2x. Right? Let's clean this up. F prime of x equals, right, the 2 should really go in front. You could also, if you wanted, factor out the e to the 2x. All right, that would be really helpful if we were solving. For this, it doesn't matter so much. But let's rewrite that nicer. So 2x cubed e to the 2x plus 3x squared e to the 2x. And if we were solving, we would want to factor out the x squared and the e to the 2x. But otherwise, it's fine like that. All right, so let's do the next one. All right, so we have, this is a nice simple one. All right, so e to the negative 2x. All right, so we're going to have our derivative is going to be exactly what we have times the derivative of the exponent. So p prime of x equals e to the negative 2x squared, and that's going to be times the derivative of negative 2x squared. Well, the derivative of negative 2x squared is negative 4x. So p prime of x will be negative 4x times e to the negative 2x squared. And there we go. Fortunately, that one didn't take up a lot of space because the other one did. All right, another chain rule with the product rule, because our exponent is a product. All right, so this is going to be our derivative, h prime of x, is going to be exact copy e to the e to the x natural log of x power, but then times the derivative of x natural log of x. All right, well, that one, the u is x. The derivative of that is 1. The v is natural log of x. And the derivative of that is 1 over x. Okay? So this is going to be e to the x natural log of x times the first, which is x, times the derivative of the second, which is 1 over x, plus the second times the derivative of the first. So that would be 1 times natural log of x. I'll write the 1 in just to make sure that that's clear. All right, well, the 1 over x, to x times 1 over x is just 1, and 1 times natural log of x is just natural log of x. So our derivative here is going to be e to the x natural log of x times 1 plus the natural log of x. All right, and we could write it like that, or if we want to distribute, if you think that looks nicer, h prime, and now if we were solving, we'd want it factored, but we could also write it, so this is fine, or we could write it as e to the x natural log of x plus, I don't know if this looks any better. You know what? Let's just leave it factored. I think it looks better factored than having 2e to the x natural log of x. All right, let's look at the next one. This one is just a straight product rule. U equals 2x squared plus 3. The derivative is 4x. V is e to the x, and of course its derivative is e to the x. All right, so we have g prime of x equals the first, so that would be 2x squared plus 3 times the derivative of the second, which is e to the x, plus the second times the derivative of the first, so plus 4x e to the x. All right, and I think that looks as good as it's going to look. All right, let's try the next one. All right, so here we have a chain rule because we have more than just an x in that we're taking the natural log of. All right, so what we're taking the natural log of is e to the 2x plus 1. Its derivative is going to be the exact copy e to the 2x times the derivative of 2x, and of course the derivative of the 1 is just 0. Right? So that derivative here will be 2e to the 2x. So our full derivative is j prime of x is going to be the derivative of what we're taking the natural log of, or in this case 2e to the 2x, divided by what we're taking the natural log of, e to the 2x plus 1. There we go. Let's look at the next one. All right, so same thing. U is 3 minus 2x. That's what we're taking the log of. The derivative would just be negative 2. Right? I'm just taking the derivative there of the x term. The rest would be 0. All right, so now our derivative f prime of x is going to be that derivative, negative 2, over what we're taking the natural log of, 3 minus 2x. And there we're done. Another one done. So these aren't too bad. You know, taking the derivative with natural log and e to the x are pretty easy. All right, so we're going to find the first and second derivatives. That might take us a little longer. All right, so first of all, let's rewrite that. So we have k of x equals, and actually, yeah, so I'll just write it in green, but we're not taking the derivative yet. We're just rewriting this. Natural log of 5x minus 2 to the 1/2 power. Well, we can use power of powers rule and make that a coefficient, and I think that would be easier. So k of x equals 1/2 natural log 5x minus 2. Now, in fact, it's always going to be easier if you simplify first. All right, so now we can take the first derivative. So k prime of x equals, all right, so actually let me write what we're taking. So what we're taking the log of, u here, is 5x minus 2. Its derivative is 5. All right, so that's what's going to go in the numerator. And then 2 times 5x minus 2 will go in the denominator. So that gives us k prime of x equals 5 over 2 times 5x minus 2. And you can leave it like that, or you can distribute it. I think I'll just distribute it because I think that would be easier for taking the second derivative. So we have 5 over 10x minus 4. All right, now notice we don't have any logs in there. So the second derivative is going to be a quotient rule. So u here is 5. Its derivative is 0. V is 10x minus 4. Its derivative is 10. All right, so using the quotient rule here, k double prime of x, because this is the second derivative, is going to be the derivative of the numerator, which is 0, times the denominator, which is 10x minus 4, minus the derivative of the denominator, which is 10, times the numerator, which is 5, all over the denominator squared. All right, so let's simplify this. Well, there's only the only thing going to be left in the numerator is a negative 50. So k prime of x equals negative 50 divided by 10x minus 4 squared. Now we could reduce that, and the squaring is pretty easy, so we probably should. So we'll square just so that we can reduce. So k prime, double prime of x is equal to negative 50 divided by, so if we squared it, that would be 100x squared, and then minus, so that would be 10 times 4 times 2, so minus 80x, and then plus 16. All right, so that's what that is squared. If that wasn't so easy, I wouldn't have done it. And then we could reduce everybody by 2. So k double prime of x equals negative 25 divided by 50x squared minus 40x plus 8. Right, and you can't do anything else with that. All right, so the first derivative that describes the rate of change of k of x. And the second derivative describes the rate of change of k prime of x. Right? All right, so your first derivative is describing rate of change in your original function. The second derivative is describing the rate of change in the first derivative. All right, so now let's find the next one. All right, so product rule here. All right, so u is x squared. The derivative is 2x. V is e to the 4x. And the derivative is going to be the derivative of 4x, which is 4, times, actually maybe I'll write it out just to make sure everyone is clear. So it would be e to the 4x times the derivative of 4x. So that would be 4e to the 4x. All right, so f prime of x equals, all right, so we have the first, x squared, times the derivative of the second, so that's 4e to the 4x power, and plus the second times the derivative of the first. So that would be 2x times e to the 4x. Let's make that a little nicer. So f prime of x equals 4x squared e to the 4x plus 2x e to the 4x. So that's our first derivative. Oh, and look what happened now. Now we've got two product rules to deal with. All right, so, and you know, the second one is almost the same as what we started with, except it's a 2x and not an x squared. We'll just do we'll do two separate product rules again. So u here on this one is 4x squared, and the derivative is 8x. V here is e to the 4x, and of course we just wrote it up above there. That would be 4e to the 4x. All right, and then over here, u is 2x, and the derivative is 2. And v and dv is still the same thing. So v is still e to the 4x, and dv is still 4e to the 4x. All right, so now let's take the derivative again. All right, so f double prime of x equals, all right, so hope this all fits here. The first, so 4x squared times the derivative of the second, so that would be 4e to the 4x. Plus, so we're still dealing with the first product there, the second times the derivative of the first, so plus 8x times e to the 4x. Right, and then plus, we got to deal with the 2x e to the 4x. the first, which is 2x, times the derivative of the second, which is 4e to the 4x, and then plus the second times the derivative of the first, so plus 2e to the 4x. Let's clean this up. All right, so f double, what happened to my f? F double prime of x equals, so that would be 16x squared e to the 4x plus 8x e to the 4x. Oh, you know, we could combine. We have some like terms here. This one and this one could be combined, right? Because their x is the same power and the e is the same power. So that would be 8x e to the 4x plus 8x e to the 4x. So that would be 16x e to the 4x. May as well do that. And then plus 2e to the 4x. And there we go. There's our second derivative. So especially sometimes on these product rules, the derivatives get worse as you go to from the second derivative to the first derivative to the second derivative and so on. All right, so now we're just going to find a couple derivatives here. All right, so the first one, the quotient rule. All right, so in the numerator there we have natural log of x. Its derivative is 1 over x. Denominator is x minus 2. Its derivative is 1. All right, so we have, and I won't write out the quotient rule again. I think we can all remember it, right? So t prime of x equals the denominator times the derivative of the numerator. So it'd be 1 over x times x minus 2. And then minus the numerator times the derivative of the denominator. So that would be 1 times the natural log of x all over the denominator squared. Now we need to clean that up a bit. Why don't we just multiply everybody by x to get rid of that 1 over x? We won't even distribute it. We'll just multiply everybody by x, all three terms there. So the x and the 1 over x will cancel, so that would be t prime of x equals, so that would be just x minus 2 minus x times the natural log of x all over x times x minus 2 squared. And there we go, that's our derivative. All right, we're going to do the quotient rule again. All right, so this time u is e to the 2x. The derivative would be e to the 2x times the derivative of 2x. So that would make that 2e to the 2x. The denominator is x cubed. The derivative is 3x squared. All right, so we're going to have p prime of x equals the derivative of the numerator, so that would be 2e to the 2x times the denominator times x cubed minus the numerator times the derivative of the denominator. I'll put the, it doesn't matter who goes first. We're going to kind of clean that up a little bit afterwards. So I'll just put the 3x squared first. Or actually, I'll be consistent. I'll put the e first. So minus the numerator, which is e to the 2x, times the derivative of the denominator, which is 3x squared, all over x cubed squared. All right, now let's clean that up. All right, so we have 2, let's put the x cubed first, 2x cubed e to the 2x minus 3x squared e to the 2x all over x to the 6. Now sometimes we might want to factor some things out, right? And just put this in factor form. So this is fine, but let's do this in factored form as well. So p prime of x equals, so we could factor out the x squared, and we could factor out e to the 2x. Right, and if we do that, we'd be left with 2x in the first term and then a minus 3 all over x to the 6. So 1 is not necessarily better than the other, but if we were solving, right, it would make that a lot easier to solve if it were factored. So I'll put it in factored form too. All right, and this one is done. I'll know when we're finished when we get to a whiteboard practice. All right, so we're going to find the second derivative here. This one's a product and a quotient. I had to choose a difficult one, right, to find the second derivative on. Oh, we already, what did we already find? I don't know what this is referring to. That one says find the second derivative. Oh, you know what? It's that one. We're going to find the second derivative on that one. I didn't finish, because now that I factored out that x squared, which I should reduce. So I should at least factor out the x squared, because I forgot to reduce. Right? So notice this could be reduced. So our final answer, p prime of x equals e to the 2x times 2x minus 3 divided by x to the 4th. So I would at least factor out that x squared just to be able to reduce like we did right there. All right? So that's going to be our final answer. And then we're going to take the second derivative, which is why this is over here, because that was the first derivative we just did. All right, so now let's do the second derivative, so just to give ourselves a challenge here. All right, so u is e to the 2x times 2x minus 3. The derivative, so let's write down all the parts here. Let's just call it, we need another letter, j and k, right? Because we have a product here. So j part here would be e to the 2x, and dj would be 2e to the 2x. And then k would be 2x minus 3, and then dk would be 2. So the derivative of just the numerator is going to be the first, which is the e to the 2x, times the 2, the derivative of the second part, and then plus the derivative of the first, which is 2e to the 2x, times the second. All right, so we'll clean that up. So du is 2e to the 2x plus 2e to the 2x times 2x minus 3. All right, and then the denominator at least is easy. X to the 4th, and its derivative is 4x cubed. All right, let's try and do this derivative. And squeeze it in this tiny little space over here. Let's see if I can do it. I'll try to write small. All right, so p prime of x equals x to the 4th times du. So that's going to be all of that, but not stuff. So, oops, I'm looking at the wrong line. 2e to the 2x plus 2e to the 2x times 2x minus 3. And then minus, I couldn't squeeze it all in, 4x cubed times e to the 2x times 2x minus 3. All over x to the 4th squared. All right, so we're going to have to distribute here and then pull out common factors. All right, otherwise, it's a mess. Well, you know what we could do? We could at least reduce, because we could pull out an x to the 3rd. All right, so p prime of x equals x cubed times, let's just, gosh, what to do with the x? And we'll just put in parentheses, there we go, x, and then 2e to the 2x plus 2e to the 2x times 2x minus 3 minus 4, and then times e to the 2x times 2x minus 3. What's going to kill me is these parentheses. All over x to the 8th. So now we could reduce that part at least and have x to the 5th, and that part's gone. All right, I think that looks icky, and let's distribute because it probably can't look any less icky. Let's at least distribute some of it. So we get rid of some of these parentheses. P prime of x equals, how about we distribute the x? It's not doing much good there anyway. So 2x e to the 2x plus 2x e to the 2x times 2x minus 3. We could distribute the 4 minus 4e to the 2x times 2x minus 3. At least we got rid of some of these parentheses. Divided by x to the 5th. I say that's fine. We could factor out the e's, but I don't know if it made it any better. Actually, they're all e to the 2x. All right, let's factor out e to the 2x. All right, so p prime of x equals, so e to the 2x, and then we'd have 2x plus, oh yeah, that will make it better, 2x times 2x minus 3 minus 4 times 2x minus 3. Oh, now we could combine like terms. All over x to the 5th. And this problem just keeps on going, doesn't it? All right, let's just simplify this. P prime of x equals e to the 2x times, we've got 2x plus 4x squared minus 6x minus 8x plus 12, right? All over x to the 5th. And now we can combine some like terms. So final answer. Oh, this isn't p prime. This is p double prime. Oh, I'll have to go up there and fix that. This is a second derivative. P double prime of x equals e to the 2x times, we've got a 4x squared, we've got a negative 12x plus 12 all over x to the 5th. Who would have thought? That looks much nicer. All right, so I'm going to scroll up a little bit, and let's fix that. So this took some space. All right, but notice it kept getting better. And so sometimes it's, a little moral of the story here, a little easier to simplify a little bit at a time. All right, so it's a little less scary just to pull out the x cubed. And then you're like, well, everyone's got an e to the 2x. Maybe we should put out the e to the 2x. Oh, look at that. We have a bunch of like terms we can combine. So that doesn't look too bad at all. P double prime equals e to the 2x times 4x squared minus 12x plus 12 all over x to the 5th. There's our second derivative. And I'm not taking the third. Right, so we're going to find the tangent and normal lines. And we're going to do, I think that's our last problem. I think we have 2 problems left. Yep, 2 problems left. And these ones, just the first derivative of tangent and normal line. It's not too bad. This is not going to be too bad. All right, so u is natural log of x. The derivative of the numerator is 1 over x. The denominator is 4x. The derivative is 4. So dy dx will be the denominator, which is 4x, times the derivative of the numerator, which is 1 over x, minus the numerator times the derivative of the denominator. So it'd be 4 natural log of x. All over 4x squared, all squared. All right, so now we can just simplify that. dy dx equals, the x's will cancel. So that's now 4 minus 4 natural log of x all over 16x squared. Lots of 4's in there. We could reduce. We could pull out a 4 and we'd have 1 minus natural log of x over 16x squared. That would cancel. That would now be a 4. So our derivative now, dy dx, is equal to 1 minus natural log of x divided by 4x squared. All right? So it makes sense to just reduce a little bit. All right, so now let's find the slope of the tangent line. So we have, and x is 1, so we're evaluating at 1. That would be 1 minus natural log of 1 divided by 4 times 1 squared. All right, so natural log of 1, all right, in other words, what would you have to raise e to get 1? Well, that would be 0. So that's 1 minus 0 divided by 4, that's 1/4. All right, we need the point. All right, so x is 1, so that's going to be y equals natural log of 1 divided by 4 times 1. That's just going to be 0, because it'd be 0 over 4. So this is the point 1, 0. So it's an x-intercept. So now the equation of the tangent line. Would be y minus 0, or just y equals, and then 1/4 x minus 1. We could leave it like that, or we could make it y equals 1/4 x minus 1/4. Either way. Now we need the equation of the normal line. Actually, I'll write something different. I'll write in blue. All right, so the slope is going to be the negative reciprocal because the tangent line and the normal line are perpendicular. So that's going to be -4. And the point will still be the same. All right, so that'll be y equals 4 times x minus 1, or y equals 4x minus 4. And there we go. All right, so we have found the tangent line and the normal line. This one wasn't so bad. Usually if you're given natural log, you're usually given like things that are pretty easy to find, that you can get exact values for. All right, this is the last one. This one is a product. All right, so u is e theta. The derivative would be e theta. And then v is 5 sine theta minus 4 tangent theta. So the derivative will be 5 cosine theta minus 4 secant squared theta. All right, so the derivative of tangent theta is secant theta, or secant squared theta. All right, so now we have f prime of theta equals, all right, so the first, which is e theta, times the derivative of the second. So that would be 5 cosine theta minus 4 secant squared theta, and then plus the second times the derivative of the first. So e theta, and then 5 sine theta minus 4 tangent theta. And, well, we can maybe make it look a little bit better. Let's just factor out the e theta. Right? And then we'd have 5 cosine theta minus 4 secant squared theta plus 5 sine theta minus 4 tangent theta. About every trig function in the world there. All right, so that's it. All right, so we've looked at finding derivatives of exponential functions when e is the base, when something else is the base, although my review here had all e is the base. Let's do one. Maybe I'll do one more. All right, so f theta equals, okay, so what if it was 2 to the 4x times x cubed. All right, I didn't have too many. I basically had e and natural log. So let's just do, actually, you know what? I'll do 2 more examples before I end this tape. And we're going to have 1 not be e and 1 not be natural log. All right, so here's the first. F of x equals 2 to the 5x power times x to the 4th. Right? Let's do a quotient rule, a product rule. So u equals 2 to the 5x power, right? And then the derivative is going to be the exact same thing, times the derivative of 5x times natural log of 2. All right, so that's going to be 2 5x times 5, the derivative of 5x is just 5, natural log of 2. Let's just rewrite that a little bit. Let's put actually that looks fine. We'll leave it like that. The 5 does look better in front of the natural log of 2. And then v is x to the 4th, and so the derivative would be 4x cubed. All right, so this is going to be, so f prime of x equals the first, which is 2 to the 5x power, times 4x cubed, and then plus the second, which is x to the 4th, times 2 to the 5x power times 5 natural log of 2. Let's make that look a little nicer. F prime of x equals, let's move the 4x cubed in front. So 4x cubed times 2 to the 5x power plus the 5 can go in front. So 5x to the 4th times, I don't know where to put the natural log of 2. I guess I'll put that next. Natural log of 2 times 2 to the 5x. And there we go. There's our derivative. All right, I'll do one more on the next page. So let's do one with log. That's not e. All right, so I don't know. Let's make it like some of the other ones we've seen. We'll do it like, let's just do we'll do another. We'll do another product, I guess. All right, so g of x equals maybe we can throw in, I know. Let's do log, let's just do a chain. All right, so log base 6 of secant theta. Actually, let's do a secant 5 theta. All right, we'll do that. All right, so g prime of x, we're going to have, oops, I don't know how that happened, the derivative of secant 5 theta all over secant 5 theta times, I guess I'll put it first, natural log of 6. All right, so the derivative of secant theta is going to be secant theta tangent theta. So g prime of x equals, and then we're going to have to take the derivative of the 5. So this would be 5 secant 5 theta, that looks almost like a 6, tangent 5 theta, all divided by natural log of 6 secant 5 theta. Right? So just a little reminder of how, oh, it's 40 minutes, how to take the derivative with log. And that's going to end my review. So thanks for watching, and bye for now.